Hi, I'm Xingyuan. I'm glad to present our work Overcoming Knowledge Barrier, Online Imitation Learning from Observation with Pretrained World Models. A little bit of background, we studied imitation learning from observation with pre-trained models. State-of-the-art methods like BCO and AIM are doing two steps. Step 1, they use pre-trained models to inference the missing actions from the demonstrations. Step 2, they use behavior cloning to learn the policy. Both of these steps create errors and influence the final performance. In this work, we try to better understand these errors. We propose two knowledge barriers. The embodiment knowledge barrier characterizes the lack of knowledge of the pre-trained models on the task at hand, while the demonstration knowledge barrier captures the lack of knowledge of the learned policy on unsupported regions of the demonstrations. We show the barriers exist on both of the algorithms by comparing them with the oracle version, which makes perfect action inference. Then we propose simple yet efficient solution for each of the barriers. For the embodiment knowledge barrier, we propose to allow the agent to interact with the environment and collect new trajectories to fine-tune their model. We find that we also need to sample from the dataset that used to pre-train the world models as a regularizor for preventing the world model to overfit the new trajectories. For the demonstration knowledge barrier, we propose to train an additional surrogate reward model to enlarge the support regions. The surrogate reward model provides a weak signal on the unsupported regions and guide the policy with reinforcement learning. We implement this proposed solution upon AIM to have AIM no barriers. As a result, we showcase that AIM no can efficiently solve the two knowledge barriers and significantly outperform the baseline. With AIM no, we only need as few as 5 demonstrations to achieve near expert performance. We also benchmark AIM no on 15 tasks from DeepMind control suite and the meta world, and the result demonstrate the extreme sample efficiency compared with other SOTA algorithms. Please check out our paper for more results.